I've finally gotten around to doing something that I've wanted to do for a really long time, and that's gears. Specifically, a parametric gear generator that makes solids that you can print, laser cut, or CNC right away from your browser. So here we go. The way we get here is from grid space, there's Kirimoto, Carve Control, and Mesh Tool. And Mesh Tool is what I'm going to show you today. It's a lesser used tool. It's not nearly as developed as Kirimoto, but it's super useful for a lot of things. So I'm going to hop right in. We can go add gear, and here you have your gear generator parametrically. The only thing that matters for gears meshing is that these bottom settings be the same between two sets of gears. So I'm going to start with a really simple 20-tooth gear, just create it. It's going to show us a couple of things that we really need to know. You saw in the bottom left-hand corner the pitch radius. Pitch radius is essentially how gears mesh, and it's a line that runs through about the middle of the tooth. And you see here that it's 30, and from here to here, 25, so 30 is this line right here. And if I zoom over to the top and zoom in, you can see that line right here, the pitch radius is right about there. So if I generate another gear, and I'm going to make it with 10 teeth, and we'll look at the pitch radius on that one. It's 15, which you can see down here. Let's go get that gear, let's grab it, and let's move it over to the right. And you'll notice that the pitch radius on that one is 15, and so 30 plus 15 is 45. 45 is basically 25, 35, 40, 45, which should actually be right in the middle of that gear, and it is if I push it over just a little bit more. And so what that tells you is if I want to make a 2-to-1 gear ratio, I can take these two pitch radiuses, add them together, and in my CAD program, that's the distance between the centers of the two gears if I'm going to make them. All right, so that's just very basic how to make two gears that are going to work together. There are a couple of other things that you're going to want to pay attention to, and a couple of other features that are kind of interesting. So one thing is that you want to sometimes adjust the amount of play or tolerance in here if you're going to 3D print things. And in that case, you're going to mess with the tooth offset down here. And that is going to shrink the tooth a little bit inside, give you some play for 3D printing. And for helixes and things like that, they'll show you in a minute, you're going to want to increase that a little bit so that they don't bind up together. The other thing is you can add chamfers for 3D printing. So let's go and try that real fast. I'll show you what that looks like. And that way you can avoid an elephant foot, and it also just sort of like looks nicer. So here you've got a chamfer. You can see that right around the edge here. That's kind of aggressive. You probably don't want to use a whole millimeter. Probably something more like a 0.5 millimeter would be good on a gear. Totally depends on the gear size. All right. And then of course you've got your shaft diameter in the middle here, and that is optional. If you set that to 0, it's going to generate a solid gear. I don't know how useful it is for you, but it's an option. And then another fun thing is that we can add a twist angle to this. So let's say 4 or 5 degrees. Let's make the Z height 10, and now we have a helical gear. And if you want to turn the helical gear into a herringbone, you can basically just mirror that and then select all and Boolean union, and I now have a herringbone gear. So that's kind of cool. Let me delete that for a second. So center it. So there's our herringbone gear. We can obviously resize that. So let's isolate the Z axis. So you can obviously resize that. That's an easy way to make herringbone gears. And then when you make the one that mates this, you have to basically invert it or mirror it, because that's the only way the teeth are going to match together. Also with herringbone gears, this is a good place where you're going to want to probably add a little bit more of a tooth offset. So for helix and these herringbones, the printing with these typically binds up a little more, so you need to give them a little bit more play. And also with these, you're going to want to maybe do a chamfer. So let's see. I'm excited to progress this a little bit further. I'm going to be adding a sketch interface to the mesh tool so that you can export the 2D drawings and bring them into your CAD program, not just work with the solid models that were produced inside a mesh tool. Hope this is useful. Love to hear your feedback, and have fun with it. Thanks.